The Meters 3 weighed just under 8 pounds. It used an 8-inch barrel and fed from a 30-round magazine. Its body was 2 halves of stamped sheet metal, welded together down the middle. Yet it was not built for the riflemen crossing open ground. It was built for men who already had their hands full. Tank crews worked inside cramped steel turrets. Drivers gripped wheels on torn roads. Radio operators carried heavy sets and spare batteries. Paratroopers jumped with everything strapped to their bodies. That narrow requirement grew into a vast program. A company that stamped car headlights was handed the contract. More than 600,000 of the guns came off its line. The weapon then broke out of its assignment. It reached the hedgerows of Normandy, the frozen roads of the Ardennes, the mud of Pacific Islands, and the tunnels of Vietnam. It gave up range to stay small. It gave up refinement to stay cheap. Every pound it saved, every dollar it saved, was paid for somewhere the soldier would eventually feel it. It was named after a tool. Mechanics used a device shaped almost exactly like it to push grease into engine fittings, and the resemblance was too plain to ignore. Soldiers looked at the stamped tube, the thin wire stock, the blunt muzzle, and called it the grease gun. The name was not affectionate at first. It was a verdict. This did not look like a serious weapon. It looked like something left behind in a motor pool. It was neither a miniature Thompson nor an oversized pistol. It occupied the space between them. The Thompson was a machined masterpiece that cost as much as a car and consumed the exact tools and skilled hands the war needed everywhere at once. The pistol was cheap and small, but could not deliver automatic fire when a man needed a wall of it. The Meters 3 was designed to sit in the gap. It was meant to be cheap enough to build by the hundreds of thousands, simple enough to be made by workers who had never touched a gun, and good enough to keep a man alive at close range. Nothing more was asked of it. That was the point. The question that produced it was not about excellence. It was about arithmetic. How do you arm millions of men when the good weapon costs too much and takes too long to build? The answer would embarrass the people who found it. It would be crude. It would be plain. It would be a gun that a proud army almost did not want to admit it had adopted. And it would refuse to leave. The weapon, designed as a wartime expedient, a thing meant to be used up and forgotten when the fighting stopped, would outlast the war that made it. It would outlast Korea. It would outlast Vietnam. It would sit clipped inside American tanks after the Cold War ended, half a century after the first one was stamped. Its story would travel from headlight factories to airborne drops, snowbound European roads, island beachheads, frozen Korean ridgelines, foreign armories, tunnel fighting, and finally the turrets of tanks rolling through the desert in 1991. Chapter 1. The gun that cost $200. The Thompson was everything a submachine gun should be. That was exactly the problem. It was beautifully made. It was accurate. It threw .45 caliber slugs in a dense, controllable stream, and the men who carried it trusted it with their lives. In the years before the war, the United States had a submachine gun that worked. What it did not have was a way to build enough of them, fast enough, cheaply enough, for a war about to swallow the entire globe. The number was the barrier. A pre-war Thompson cost roughly $200 to produce. In the money of the war years, that was an enormous sum, several $1,000s in today's terms, for a single shoulder weapon meant to be handed out by the crate. The gun was cut from solid steel. Its receiver was milled. Its parts were forged and machined to close tolerances by skilled hands on precise machines. Every one of those hands and every one of those machines was needed 100 other places. Aircraft needed them. Artillery needed them. Tanks and engines and ships all needed the same finite supply of tool steel, machine tools, and trained machinists. That was the hidden cost of quality. The Thompson did not just cost dollars, it cost capacity. Each one built tied up a lathe and an operator who could have been making something else the war also could not do without. The Army tried to make the Thompson cheaper. Engineers simplified it into the Meters 1 and Meters 101, stripping away the expensive refinements, the finned barrel, the elaborate delayed blowback lock, the fine adjustable sights. They drove the price down to roughly $40 to $45 a gun. That was a real achievement. It was also not enough. $40 was still a large amount of machining time for a weapon the Army now wanted to issue not in the thousands, but in the millions. A simplified Thompson was still a Thompson underneath. It was still cut and milled from steel. It still fed the same appetite for tools and men. Stand for a moment beside the officer whose job was to make the schedule work. He was not a soldier in a foxhole. He was a planner at a desk in the Ordnance Department, holding a production forecast and a demand figure that would not reconcile. The Army wanted submachine guns for tank crews, for paratroopers, for engineers, for military police, for the men who could not carry a full-length rifle and still do their jobs. The factories could not deliver Thompsons at that scale in the time available. Every month, the gap between what was needed and what could be built grew wider. No amount of patriotism closed it. Only arithmetic could. There is a comfortable story that says the Thompson was replaced because it was a bad weapon. That claim requires restraint. The Thompson was not bad. It was, by almost every measure a soldier cared about, superior to the gun that came after it. It was more accurate. It was more solid in the hand. Men who were later issued the cheaper replacement often wished aloud for a Thompson back. The Thompson was not retired because it failed. It was retired because it succeeded at a price the war could not afford to pay in bulk. The problem was never the gun. The problem was the ledger. Those qualities defined the Thompson's promise. Those same qualities carried a price. Its excellence was built into its cost, and its cost was built into its steel, and its steel was the exact material the entire war effort was fighting over. Every Thompson that reached a soldier's hands was a small victory purchased with resources that a dozen other programs were also demanding. Multiply that by the millions of weapons a world war consumes, and the equation broke. So the Ordnance Department began asking a different question. Not how do we make a better submachine gun, not even how do we make a cheaper Thompson. The question became something more radical, almost heretical to men trained to respect fine machining. How little could a working submachine gun actually be made of? How much of the craftsmanship could be thrown away before the weapon stopped functioning? It was an uncomfortable question for a proud arms establishment. American ordnance took pride in precision. Precision was the national style. The idea of deliberately building something rough, something stamped and welded rather than milled and fitted, ran against every instinct the institution had. And yet the numbers left no room for pride. The war would be won by output as much as by quality, and output meant surrendering some of the quality that output could not afford. The Americans did not have to imagine what such a weapon might look like. Across the Atlantic, another army had already been forced to the same wall and had already accepted an answer that no American had yet been willing to look at directly. Chapter 2. The Ugly Gun That Worked. The British weapon looked like plumbing. It also came off the line by the millions. In 1940, Britain stood nearly alone and nearly empty-handed. The retreat from Dunkirk had stripped the British army of much of its equipment, left behind on the beaches of France. The island needed weapons, and it needed them at a speed and a price that fine engineering could not deliver. There was no time to machine masterpieces. There was barely time to breathe. Out of that desperation came the Sten. The Sten was almost shockingly crude. It was a tube, a bolt, a spring, a simple trigger group, and a magazine that stuck out sideways. Much of it was stamped from sheet metal and welded or pinned together rather than milled from bar stock. It had no wooden furniture, no fine sights, no graceful lines. Soldiers mocked it. They called it the plumber's nightmare and the Woolworth gun, after the cheap goods sold in the discount stores. It rattled. It felt like something assembled in a shed. And it poured out of British factories in numbers the Thompson could never have matched, at a fraction of the cost, made largely by workers and workshops that had never before produced a firearm. That was the lesson America could not unlearn once it had seen it. The Sten proved a specific and unwelcome truth. An efficient submachine gun could be made at very small unit cost by rapid production line methods using stamped and welded parts and unskilled labor. The weapon did not need to be beautiful to work. It needed to feed, fire, and function. Everything beyond that was refinement. And refinement was exactly what a war economy could no longer afford to spend on a close-range weapon. Consider the man who had to carry that lesson into a room full of skeptics. Colonel Rene Studler headed small arms development for the Ordnance Department. He was an officer willing to be embarrassed. He looked at the crude British gun and saw not an insult to American craftsmanship, but a solution to an American problem. He became an advocate for building something similar, something deliberately cheap, something that abandoned the machine tradition entirely. That was not an easy position to hold in an establishment that measured its worth in tolerances and finish. There is a temptation to say the Americans invented the disposable submachine gun. That claim needs correction. They did not invent it. The Sten came first, and behind the Sten stood the German designs that had shown the way toward stamped construction even earlier. What the Americans did was study the idea, absorb it, and then push it in their own direction. The Meters 3 that followed was not a copy of the Sten. But it would never have existed in the form it took, at the moment it took it, without the Sten proving first that the whole approach was sound. The originality was in the execution, not the concept. The concept itself demanded a trade every proud engineer resisted. To gain output, you surrendered craftsmanship. To gain speed, you surrendered finish. To gain a price low enough to arm millions, you surrendered the very qualities that made a weapon a source of pride. The cost of the cheap gun was not paid in dollars. It was paid in institutional pride, in the willingness of a precise culture to build something it found ugly. Studler and the men around him were prepared to pay that price. They understood what the ledger demanded. If the United States was going to put an automatic weapon into the hands of every tank crewman, every truck driver, every paratrooper, every second-line soldier who could not manage a rifle, It could not do it with machined guns. It would have to do it with stamped ones. It would have to accept ugly. But accepting the idea was one thing. Building the object was another. America's first serious attempt to produce a cheap submachine gun of its own was already underway, and it was about to fail so badly that it nearly discredited the entire approach before the Meters 3 was ever drawn. Chapter 3. The gun before the gun. The Meters 2 was supposed to be the cheap answer. It nearly killed the whole idea. Before the Meters 3 existed, the Ordnance Department pursued a different weapon meant to solve the same problem. It was designed by George Hyde, a talented gun designer who understood submachine guns as well as almost anyone in America. His weapon was to be built by Marlin Firearms, and on paper it was promising. It was lighter than the Thompson by nearly 2 pounds. It used standard Thompson magazines. It fired at a moderate rate that made it controllable. In testing, the early prototypes performed well enough to earn a standardized designation as the Meters 2. The trouble lived in how it was to be made. To hit the low cost the Army wanted, the design leaned on powder metallurgy, a process of forming metal parts from compressed and heated powder rather than machining them from solid stock. In theory, it was a shortcut to cheapness. In practice, Marlin had little experience with it, and the company ran into serious difficulties trying to make it work at scale. The shortcut turned into a trap. To escape it, the design had to be reworked to use conventional machined steel after all, which erased much of the cost and production advantage that had justified the gun in the first place. Then the finished guns arrived, and they did not behave like the prototypes. Testing revealed functioning problems that had not appeared in the hand-built early samples. The production weapons suffered an excessive number of malfunctions. Engineers made modification after modification. The problems did not resolve. A weapon that had looked like the answer became a weapon that could not be trusted to fire reliably, and a weapon that cannot be trusted to fire is not a weapon at all. Stand beside George Hyde during that period, because his position was a peculiar one. He was watching one of his designs struggle toward failure, and at the same time he was being drawn into the work that would replace it. Ordnance had not staked everything on the Meters 2. As backup insurance, in the middle of 1942, the department had commissioned an alternative. Studler, Hyde, and a production engineer named Frederick Sampson began collaborating on a different concept entirely, a stamped and welded sheet metal gun that owed its philosophy to the Sten. Hyde was, in effect, helping to build the thing that would make his own troubled weapon unnecessary. The Meters 2 program ended without ceremony. Production guns did not arrive until May of 1943, and only about 400 were ever built. The contract was canceled on the 9th of June, 1943. A weapon that had received a full, standardized designation, that had been meant to arm the Army cheaply, vanished into a footnote after a few hundred examples. It is tempting to treat the Meters 3 as America's confident first attempt at a cheap submachine gun. The record does not support that. The Meters 3 was not a first try. It was insurance against a first try that had already begun to fail. It was the backup plan, started quietly while the main effort was still alive, and it inherited hard lessons paid for in the Meters 2's collapse. The most important lesson was the simplest one. A clever manufacturing shortcut that a company cannot actually execute is worse than no shortcut at all. Powder metallurgy had promised cheapness and delivered malfunctions. The men designing the Meters 3 would not repeat that mistake. They would build their gun around a process the manufacturer already knew cold. That decision would send the contract not to a gunmaker at all, but to a company that had spent its life stamping ordinary steel into ordinary objects. And it would send George Hyde back to his drawing tools, to design a weapon even plainer than the one he had just watched fail. Chapter 4. 2 months to a weapon. A masterpiece of gun design took years to perfect. This one took a single season. The men who built the Meters 3 were not given time to be elegant. The requirements were set in motion around October of 1942, and formal approval for production came in December of the same year. Roughly 2 months separated the concept from the decision to build it. In the world of firearms development, where new designs are refined across seasons of trials and years of adjustment, that pace was almost violent. It was possible only because the men involved refused to design the gun the traditional way. George Hyde handled the design of the weapon itself. Frederick Sampson handled the tooling, the far less glamorous question of how the thing would actually be produced. That division mattered more than it sounds. On most guns, the designer draws the ideal weapon, and the production engineers are left to figure out how to make it. Sampson worked the other way around. He was there from the beginning to make sure that every part Hyde drew could be stamped, pressed, or welded on equipment that already existed by workers who already knew how to run it. The gun was designed toward the machine, not the machine bent toward the gun. Studler pushed the whole effort forward and shielded it inside the Ordnance Department. The design that emerged was ruthless in what it discarded. There was no wood anywhere. There was no milled receiver. The body was formed from 2 halves of stamped steel welded together down a seam. The stock was not a stock in the old sense, but a bent length of steel wire that slid in and out to set the length. The sights were fixed, a simple aperture set for a range of 100 yards, with no adjustment because adjustment cost money and a close-range gun did not need it. The gun fired only on full automatic. There was no selector switch, no semi-automatic setting, because a selector was another part to make and another thing to break, and the designers judged that a trained man could fire single shots by controlling the trigger himself. The weapon was submitted for trials under experimental designations, and the version that succeeded proved the concept could work. In accuracy testing, it scored 97 out of 100. In endurance testing, it fired more than 5,000 rounds with only a small number of feeding failures. Those were not the numbers of a precision target arm. They were the numbers of a weapon that did its narrow job and kept doing it. For a close-range automatic meant to be issued by the hundreds of thousands, they were more than enough. The Army recommended adoption on the 12th of December, 1942, and formal approval followed on the 11th of January, 1943. There is a myth that clings to weapons like this one, the myth of the lone genius. Popular retellings like to say that one brilliant man sat down and invented the grease gun. The record shows something more ordinary and more honest. The Meters 3 was the product of at least 3 men and 1 foreign example. Hyde shaped the weapon. Sampson shaped the way it would be made. Studler drove it through the institution. And behind all of them stood the Sten, which had already proven that the entire approach was viable. No single hand created it. It was assembled from a design philosophy as much as from steel. Speed like that is never free. The gun was designed down to the tooling, not up to an ideal. And that choice was paid for in the object itself. The tolerances were loose. The finish was rough. The gun would never feel like a fine instrument, because it had never been meant to. Every hour the designers saved by simplifying, every part they deleted, every refinement they refused, became a small compromise the soldier would eventually hold in his hands. The gun was fast to design because it asked for so little, and it asked for so little because so little was all the war could spare. There was one more thing the design assumed that had not yet been proven. It assumed that a company with no history of making firearms could stamp this weapon out reliably, in enormous numbers, without the skilled gunsmiths the Thompson had required. That assumption was about to be tested in a factory that had spent its existence making something entirely unrelated to war. Chapter 5. The company that made headlight housings. Guidelamp built parts for automobiles. Now it was asked to stamp a machine gun. The contract for the new weapon, officially the United States submachine gun, caliber 45, Meters 3, went not to a famous armory, but to the Guidelamp division of General Motors in Anderson, Indiana. Guidelamp's business was sheet metal. It stamped and formed steel into the small, pressed components of cars, the kind of work that fills a modern vehicle with parts nobody thinks about. Headlight housings and similar pressed pieces were its trade. It had presses, it had dies, it had workers who understood how to shape metal by stamping it, and it had exactly none of the traditions or bottlenecks of a gun factory. That was precisely why it was chosen. The gun was built to suit that shop. Its body was 2 stamped steel halves welded together. Almost everything about it was pressed, formed, or spot welded rather than cut from solid metal. The only real machining performed in-house was the cold swaging of the rifled barrel, the process of forming the bore under pressure. Even the bolt, the single densest piece of the weapon, was made elsewhere. The Buffalo Arms Company produced the bolts and shipped them in. The gun was less a single crafted object than an assembly of pressed parts brought together on a line that had been built for consumer goods. The result was the number that justified the entire project. The gun itself was contracted at $18.36. The bolt from Buffalo Arms added $2.58. Together, the completed weapon cost about $20.94. Against a Thompson that had once cost $200, and even against the simplified Thompson at $40 to $45, that figure was transformative. Just as important, the Meters 3 required roughly half the man-hours of a Thompson and around a quarter fewer machine tools. It did not merely cost less money, it consumed less of everything the war was short of. First production guns came off the line in May of 1943, only months after approval. Picture the worker on that line, not a gunsmith, a sheet metal hand who a year earlier might have been pressing parts for cars, now welding together the 2 halves of a weapon that would go to Normandy. That worker did not need to understand ballistics or fit parts by hand to 1/1000th of an inch. The gun was designed so that ordinary industrial skill was enough. That was the whole idea made physical. The weapon had been drawn so that people who had never made a gun could make hundreds of thousands of them. This is the moment to correct the number in the gun's own legend. It is often called the $15 machine gun, and the figure is repeated because it is clean and it is striking. That claim requires restraint. The documented, contracted cost of the complete weapon was closer to $21, not $15. The lower number likely traces back to the cost of the gun body alone in early estimates, or to the round target figure the program aimed at before the bolt and the final contract prices were settled. The $15 name endures because it captures a true thing in a false figure. The truth is that the gun was staggeringly cheap. The precise truth is that it cost about $21, and the difference matters only to those who care whether a good story is also an accurate one. The cheapness was real, and the cheapness had a price written into it. The loose tolerances that made the gun fast to stamp also made it rough. A gunsmith handling one would wince at fits that a fine weapon would never tolerate. The stamped magazine, patterned on cheap designs, would prove to be the gun's most vulnerable part. Everything that made the Meters 3 buildable by a headlight factory also made it a blunt instrument rather than a refined one. The savings were not free. They were deferred, loaded onto the weapon's character, waiting to be felt in the field. And yet, the thing worked. To understand why a gun stamped by an auto parts division out of pressed steel and loose tolerances could function reliably enough to serve for 50 years, it helps to slow down and watch it do the one thing it was built to do. It helps to follow a single round from the magazine to the ground. Chapter 6. One full cycle. Nothing about the mechanism was elegant. Everything about it was deliberate. Begin with the weapon loaded and quiet. A 30-round magazine is seated in the housing beneath the receiver. The bolt is held all the way to the rear, caught on the sear, compressed against its springs. This is what an open bolt design means. Unlike a rifle that sits with a round already chambered, the Meters 3 waits with its bolt back and its chamber empty. It is a simple arrangement, and simple was the entire philosophy of the gun. The soldier's first act is to make it ready. On the early guns, he grips a small crank-type cocking handle on the side and turns and draws it to pull the bolt rearward until the sear catches it. On the later guns, the ones without that handle, he simply pushes a finger into a recess cut into the bolt and drags it back by hand. Either way, the bolt now rests to the rear under spring tension, waiting. He releases the safety. On the Meters 3, the safety is not a lever or a button in the usual sense. It is the hinged cover over the ejection port. When that cover is closed, a small projection on its underside drops into a notch on the bolt and physically locks the bolt in place, whether forward or back. Closed, the gun cannot fire because the bolt cannot move. This arrangement has been called one of the finest safeties ever fitted to a military weapon, and the praise is deserved. It costs almost nothing to make. It is nearly impossible to misunderstand. Flip the cover up, and the gun is live. He pulls the trigger. The sear drops and releases the bolt. The twin recoil springs, wound onto two parallel guide rods that run through holes drilled in the bolt itself, drive the whole mass forward. Those guide rods are one of the quiet cleverness of the design. Because the bolt rides on the rods rather than sliding directly against the inside of the receiver, it never scrapes the stamped walls of the gun. Dirt, grit, and rough tolerances inside the body matter far less when the bolt is not touching them. The gun was built loose on purpose, and the guide rods made loose acceptable. The bolt runs forward and its face strips the top round out of the magazine, pushing it ahead into the chamber. There is no separate firing pin to trip, no hammer to fall. The firing pin is fixed, milled directly into the face of the bolt as a small, solid protrusion. The instant the round seats fully in the chamber, that fixed pin strikes the primer. The cartridge fires while the bolt is still moving forward and pressing the round home. This is the essence of advanced primer ignition blowback, and it is about as mechanically simple as an automatic weapon can be made. The cartridge burns, and the bullet leaves the 8-inch barrel at roughly 900 feet per second. The same expanding gas that pushes the bullet forward pushes back against the cartridge case, and through it against the heavy bolt. Nothing locks the bolt shut. Only its own weight and the springs resist. The bolt is heavy enough, and the .45 cartridge's pressure low enough, that by the time the bolt is driven back, the bullet has long since left the muzzle. The bolt travels rearward, the empty case is pulled from the chamber and thrown out through the ejection port, and the springs are compressed again. If the trigger is still held, the sear stays down, and the bolt runs forward once more to repeat everything. If the trigger is released, the sear rises and catches the bolt at the back. All of this happens slowly, by the standards of automatic weapons. The Meters 3 cycles at only about 450 rounds per minute. That leisurely rate is a product of the low pressure of the .45 cartridge, the heavy bolt, and springs chosen with a lighter compression than a faster gun would use. There is a myth that a submachine gun is a spray weapon, wild and inaccurate by nature. That claim needs context. The Meters 3's slow rate was not a flaw, it was an advantage. The gun recoiled gently and climbed little, and the deliberate pace meant a trained man could feather the trigger and fire single shots or short-controlled bursts almost at will. The grease gun was easier to control than faster, lighter submachine guns that emptied their magazines in a blur. The trade was in what the simplicity gave up. Full automatic only meant there was no proper semi-automatic setting for a man who wanted precise single fire without relying on trigger discipline. The fixed sights meant no adjustment for distance. The whole weapon was optimized for one job at close range and refused every task beyond it. Those were acceptable losses for a close-quarters gun. They were losses all the same. There was one part of this otherwise robust machine that did not hold up, and it was the very part the soldier's hand touched most. The cocking handle on the early guns was about to become the weapon's public embarrassment. Chapter 7. The Handle That Broke. The gun was rugged nearly everywhere. It failed in the one place the hand went most often. The original Meters 3 was cocked by a crank-type lever mounted on the right side of the housing, forward of the trigger. The soldier turned and pulled it to draw the bolt back. It was a small mechanism, more complex than the rest of the brutally simple gun, with a ratchet arrangement that let it retract the bolt through a short throw. On the drawing board, it was a reasonable solution. In the field, it became the weakest link in an otherwise tough weapon. The trouble was the steel and the treatment. The cocking assembly was made from low-grade steel and, on many guns, given poor heat treatment. That combination produced a part that was brittle, where it needed to be strong. When a gun was dropped, and guns in war are always dropped, thrown into vehicles, banged against hatches, flung down in the dirt, the cocking mechanism was prone to breaking. A soldier with a broken cocking handle had a serious problem. He could not readily draw the bolt to the rear, which meant he could not ready the weapon in the normal way. A $20 gun that could not be cocked was worth nothing at all. Ordnance units in the field found their own answers, as soldiers always do. Armorers improvised repairs by cutting a slot into the receiver and attaching a simple handle directly to the bolt, so the bolt could be dragged back by that handle through the slot. It was a field expedient, a workaround born of necessity, and it pointed almost exactly at the solution the factory would eventually adopt. The men in the field had, in effect, redesigned the gun's most troublesome feature before the engineers formalized it. The formal fix arrived with the Meters 301, standardized on the 21st of December, 1944. Its central change was an act of subtraction. The entire troublesome crank cocking mechanism was deleted. In its place, the designers cut a recessed slot into the top front portion of the bolt. To cock the gun, the soldier now simply inserted a finger into that recess and pulled the bolt straight back. There was nothing to break because there was almost nothing there. The complicated part had been replaced by a hole. To make room for the finger to reach the bolt, the ejection port was enlarged. The Meters 301 gathered up a handful of other lessons at the same time. The rear sight, which had been fragile, was strengthened with welded support ribs. A small oil reservoir was built into the pistol grip, so a man always had lubricant on hand. The wire stock was modified so that it could serve double duty as a barrel removal wrench and as a tool to help load magazines. Each of these was a small refinement, and each followed the same logic as the cocking handle fix. Make it simpler. Make it harder to break. Give the soldier one less thing to carry and one less thing to lose. There is a broad accusation that the Meters 3 was simply an unreliable weapon, and that accusation deserves restraint. The record does not show a gun that failed everywhere. It shows a gun that was fundamentally sound with one badly executed component, and that component was corrected by removing it. The enclosed action resisted mud. The guide rods kept the bolt running. The mechanism was about as robust as a stamped gun could be. The famous weakness was narrow and specific, a matter of one part made from the wrong steel, and the story is often inflated into a verdict on the whole weapon. The myth felt true because a broken cocking handle was a dramatic and visible failure. The evidence supports a narrower judgment. The gun was reliable. The first cocking handle was not. Even the fix carried a cost, in the way that fixes often create new questions. Deleting the cocking handle meant that the Meters 301 could no longer be cocked with a mechanical lever at all. A soldier now had to have a free finger and a clear grip on the bolt through the enlarged port. In wet, gloved, or awkward conditions, dragging the bolt back by a finger recess was its own small inconvenience. The enlarged ejection port also meant a larger opening into the action. The engineers judged these acceptable, and they were, but nothing in the gun's design was ever free. Every simplification removed one problem and quietly introduced a smaller one. By the time the improved gun was flowing from the factories, the argument over its cocking handle had been overtaken by events. The Meters 3 had already gone to war in its original form. Only about 15,000 Meters 301 guns were built before the fighting in Europe ended. The weapon that reached the front, that jumped into Normandy and froze in the Ardennes, was mostly the first version, cocking handle and all. And the men who received it were, for the most part, exactly the men it had been designed for. Chapter 8. The weapon for the men with their hands full. A rifleman could give both hands to his rifle. Most of the men who received the Meters 3 could not. The gun had been conceived for the soldier whose primary duty left little room for a weapon, and in the field that is precisely where it went. Consider the tank crewman. He worked inside a turret the size of a closet, surrounded by steel ammunition, and machinery, with no space to swing a full-length rifle and no way to fight from a hatch with anything long. For him, the Meters 3 was close to ideal. It was short. Collapsed, with its wire stock pushed in, it measured under 22 inches. It could be stowed in a bracket inside the turret and snatched up if the crew had to bail out and fight on foot. A Thompson was better made, but a Thompson took up room a tank did not have. The same logic reached far beyond armor. Truck drivers needed a weapon they could keep beside them without it fouling the controls. Radio operators carried heavy sets and spare batteries that pulled at the shoulders and hips, and they needed defense that did not add the length and weight of a rifle. Engineers, mortar crews, military police, and second-line troops of every kind were all men whose main burden was something other than a gun. The Meters 3 was for the men already loaded down. It gave them automatic firepower in a package they could carry along with everything else. Then there were the paratroopers. Airborne soldiers jumped from aircraft with everything strapped tightly to their bodies, and every inch and every ounce of equipment had to survive the shock of the jump and not snag on the way out. A short weapon with a collapsing stock was a natural fit. Paratroopers of the 82nd and 101st Airborne Divisions carried Meters 3s into the Normandy landings in June of 1944, dropping into the dark of France with the stamped little guns among their weapons. For men who fought scattered and close in hedgerows and villages, a compact automatic that threw heavy .45 slugs at short range was well suited to the work. Stand for a moment inside that turret with the tank loader. His world is a few feet of armored space. His hands are full of shells the length of his forearm. If the tank is hit and burning and the order comes to get out, he will have seconds to escape through a hatch and drop to open ground, and whatever he fights with next has to be something he can grab and use immediately, one-handed if need be, in a space where a rifle would be useless. That is the man the Meters 3 was drawn for. Everything the gun gave up, it gave up so that this man would have something rather than nothing. There is a tendency to imagine the Meters 3 as a frontline infantry weapon, the gun of the assaulting rifleman. That picture is misleading. The Meters 3 was, by design and by issue, the weapon of the men who carried something else first. It was a secondary arm, a personal defense weapon for troops whose job was not primarily to shoot. When it did reach frontline infantry, it was usually because supply had pushed it there, or because a soldier chose it for close work, not because doctrine made it the rifleman's primary tool. Understanding who actually received it explains both its strengths and the complaints against it. The trade at the heart of the gun was written into that role. To be short enough for a turret and light enough for a jump, the Meters 3 surrendered range and refinement. Its fixed sights were set for 100 yards, and beyond close and medium distance, it had little to offer. It was never meant to reach out. A tank crewman bailing out did not need a weapon that could hit a man at 300 yards. He needed a weapon that could clear the space around a burning tank right now. The Meters 3 was optimized for that moment and nearly useless outside it, and for the men it was built for, that was exactly the right bargain. But no bargain survives every environment. The gun that shrugged off dirt in its receiver had a weakness in the one part that fed it, and in the mud and cold of the European winter, that weakness came into the open. Chapter 9. Mud, Cold, and a Bad Magazine. The body of the gun shrugged off filth. The magazine did not. The Meters 3's enclosed action was one of its real virtues. With the internal parts largely sealed inside the stamped body, and with the bolt riding on guide rods rather than scraping the walls, the mechanism resisted the dirt, mud, and sand that plagued more open designs. In that sense, the gun was genuinely well suited to hard use. The problem lay outside the receiver, in the box of steel that held the ammunition. The magazine held 30 rounds in a double-column, single-feed arrangement. It was patterned closely on the British Sten magazine, and it inherited the Sten magazine's flaw. In a single-feed design, the two stacked columns of cartridges are funneled up to a single narrow position at the top before feeding. That narrowing is a place where things can go wrong. It demands more of the cartridges and the spring, and it is more easily disrupted by grit and grime than a staggered feed that presents rounds from alternating sides. The Thompson's magazines used a more forgiving arrangement. The Meters 3's did not. The magazine was, in the end, the least reliable major part of the whole weapon, and it was that way partly because a cheap, single-feed magazine was one of the things that made the gun cheap. The failure showed itself most sharply where conditions were worst. In the Battle of the Bulge, in the bitter winter of the Ardennes at the end of 1944, cold and mud and frozen slush tested every weapon in the American arsenal. In the Pacific, the fine grit and grime of island fighting worked into everything. In those settings, a fouled or dented magazine could produce a stoppage, and a stoppage in a close fight is a small catastrophe. Fairness demands that the causes be laid out honestly, because a jam is rarely a single thing. When a Meters 3 failed to feed, the cause might lie in the magazine, in damaged or dirty ammunition, in a lack of lubricant or too much of it in the cold, in accumulated grit, in a worn or bent magazine lip, or in simple hard use. Not every stoppage was the magazine's fault, but the single-feed magazine was the most common and the most correctable culprit, the weak point that turned up again and again in the complaints of the men who carried the gun. Picture the soldier in the Ardennes clearing that stoppage. His fingers are stiff with cold. His breath hangs in the air. The gun that fired a moment ago has gone silent with a round half fed, and he has to strip the magazine, clear the round, and seat a fresh magazine with hands he can barely feel while the fight goes on around him. This is where the price of cheapness was finally paid. Not in the factory, and not on the drawing board, but in the snow. In the seconds it took a freezing man to fix a jam that a better magazine might not have caused. There is a broad claim that the grease gun jammed constantly, that it was an unreliable weapon at its core. The evidence asks for restraint. The gun's action was reliable. Its magazine was the problem. To say the Meters 3 jammed constantly is to blame the whole weapon for the failing of one component, in the same way the cocking handle story was inflated into a verdict on the entire design. The myth felt true because a jam in a firefight is unforgettable, and because the two most memorable weaknesses of the gun, the handle and the magazine, both happened to sit in the soldier's hands. The narrower truth is that the Meters 3 was about as reliable as its magazine allowed it to be, and its magazine was cheap on purpose. For all the complaints, something changed in the men who used it. The soldiers who received the stamped little gun with open contempt, who wanted a Thompson and felt insulted to be handed a grease tool instead, began to revise their opinion once they had actually fought with it. The gun that looked like nothing proved to be something after all. Chapter 10. The gun they stopped being ashamed of. Soldiers distrusted it on sight. Then they carried it into close fighting and changed their minds. The first reaction to the Meters 3 was almost universally poor. Troops accustomed to the solid heft of the Thompson looked at the stamped tube with its wire stock and its blunt lines and did not see a weapon they could respect. It rattled. It looked unfinished. It looked, unavoidably, like the grease tool it was named for. Men distrusted the unfamiliar gun, and the distrust was made worse by the fact that it so obviously advertised its own cheapness. A soldier could feel that the army had handed him something built to a budget, and no one likes to feel that their life has been fitted to a price. What changed the verdict was use. It took time and experience for the men to recognize the rugged practicality of the new gun. In the close, ugly fighting that the Meters 3 was actually meant for, its virtues became clear. It was light, nearly 4 pounds lighter than a Thompson. It was short and easy to bring to bear in a trench, a room, a bunker, or the space beside a vehicle. Its slow rate of fire made it controllable, so that bursts stayed on target instead of climbing into the air. The heavy .45 slug hit hard at the close ranges where the gun was used. A weapon that had looked like a joke turned out to do its narrow job about as well as anything could. A gunwriter of the period captured the paradox exactly. In 1945, W.H.B. Smith described the weapon as crude in appearance precisely because its cost was less than that of a good automatic pistol. That single line holds the whole truth of the gun. Its ugliness was not an accident or a failure of care. Its ugliness was the visible form of its cheapness, and its cheapness was the entire reason it existed. To complain that the Meters 3 looked crude was to complain that it had succeeded at being inexpensive. Set against its German counterpart, the Meters 3 held its own in the ways that mattered. The German Meters P40 was a better finished weapon, a smoother and more refined submachine gun, and it is often remembered as the superior arm. But in the practical business of close combat, the two guns did similar work. Both were compact automatics with folding or collapsing stocks. Both fired pistol-caliber rounds at controllable rates. Both were meant for the same kind of fighting. The Meters P40 was the more elegant machine. The Meters 3 was the cheaper one. On the ground, the gap between them was far narrower than their appearances suggested, and the American gun could be built faster and in greater numbers for less of everything. The men who carried the Meters 3 arrived at a blunt and grudging respect for it. It was described, in later summary, as rude, crude, and effective, and the three words belong together. It was rude in its manners, rattling and rough. It was crude in its making, stamped and welded and plain. And it was effective at the one thing it had been built to do. The soldiers stopped laughing at the grease tool once it had kept them alive in a hallway or a hedgerow, and the name that had started as a sneer softened into something closer to affection. The judgment that settled on the gun was a fair one, and it did not pretend the weapon was more than it was. The Meters 3 would never be admired the way the Thompson was admired. It would never be a beautiful object or a source of pride. What it earned instead was trust, which is a different and more useful thing. A soldier does not need to love his weapon. He needs to believe it will work when he pulls the trigger, and enough men came to believe that about the Meters 3 that its ugliness stopped mattering. The trade was clear. Beauty for numbers, refinement for cost, admiration for trust. It was a trade the war was glad to make. Then the war ended. And the gun that had been designed as a wartime expedient, a thing to be used up and discarded when the shooting stopped, was supposed to disappear along with the emergency that had produced it. It did not. Chapter 11. The stopgap that would not stop. It was built for one war. It reported for the next 3. The Meters 3 had been conceived as a temporary answer, a cheap gun for a specific crisis, the kind of thing an army makes in bulk and then melts down once peace returns. Instead, it kept finding work. When the fighting in Korea began, the demand for submachine guns rose again, and production was resumed. The Ithaca Gun Company took a contract in the mid-1950s and built tens of thousands more Meters 301 guns, with something over 33,000 delivered before that contract too was cut short. A weapon that had been declared a stopgap in 1943 was still coming off assembly lines more than a decade later. The gun also multiplied into variants and offspring. A conversion allowed the Meters 3 to fire the 9mm cartridge instead of 45, by swapping the barrel and bolt and fitting an adapter to accept British Sten magazines, though only a few hundred such kits were ever made against an original hope of many thousands. Prototype versions were built around the .30 caliber carbine cartridge, chasing a weapon that could reach a little farther, in the shadow of the German assault rifles that had shown the way toward that idea. The intelligence services took an interest as well. During and after the Second World War, suppressed versions were developed, with Bell Laboratories designing a sound suppressor and roughly 1,000 produced for clandestine use, quiet guns for men who worked in the dark. Beyond America's own arsenals, the designs spread across the world. Argentina built its own near copies, the PAM series, scaled down and chambered in 9mm, with nearly 50,000 produced over years of manufacture. China built direct clones, including a copy of the Meters 301 turned out by the thousands at its arsenals. In all, the Meters 3 and its derivatives were used by more than 30 nations, from France and Greece to Japan, South Korea, Mexico, Brazil, and the Philippines. A gun designed to be cheap enough to throw away had instead become cheap enough to give away, and giving it away spread it into armories on every continent. It followed the United States into its next long war as well. In Vietnam, the Meters 3A1 served as a standard submachine gun for American forces and for the South Vietnamese Army, and it was handed down, further still, to Montagnard fighters and local militias armed by American advisors. Helicopter crews carried it as an emergency weapon against the chance of being shot down. Suppressed Meters 3A1 guns went into the hands of Force Reconnaissance Marines, Navy SEALs, and long-range patrols for quiet, close work. The enemy used it too, taking captured guns from South Vietnamese stocks. The stamped little weapon reached into some of the most specialized fighting of the era. Picture the tunnel rat, the American soldier sent down into the narrow underground passages the Viet Cong had dug. He crawls into blackness barely wide enough for his shoulders, where a rifle is far too long to bring around and a long weapon is a liability rather than an asset. In that space, a man wants something short, something he can turn in a tight corner, something that will fire the instant it is needed. The compact Meters 3, with its stock collapsed or removed, was one answer to that terrible problem. A gun drawn in 1942 for the crewman in a tank turret turned out to suit the man in a tunnel 25 years later for the same reason. Both fought in spaces where length was death. There is an assumption that the Meters 3 left service when the Second World War ended, that it was a purely 1940s weapon. The record shows the opposite. It did not fade after 1945. It multiplied, spread, and kept fighting, decade after decade, in the hands of allies and enemies and specialists, long after the men who designed it had expected it to be scrap. The stopgap had become permanent, which is the strangest fate a temporary thing can suffer. And the men who held on to it longest of all were the ones for whom it had first been imagined. They sat, as they had always sat, inside steel. Chapter 12. 50 years in a turret. Every weapon built to replace it aged out first. The cheap ones stayed. The submachine gun had a hard time in the second half of the 20th century. New weapons arrived that seemed to make it obsolete. The assault rifle combined much of the submachine gun's close-range firepower with far greater range and hitting power, and army after army retired their pistol-caliber automatics in favor of the new rifles. Newer, sleeker submachine guns arrived as well for the roles that remained. By every reasonable measure, the Meters 3 should have vanished from American service in the 1960s or 1970s, a relic of a bygone style of war. It did not vanish, because of the one role no rifle could fill as well. Inside an armored vehicle, the same problem that had created the Meters 3 in 1942 still existed in 1982. A tank crewman still worked in a space the size of a closet. He still needed a weapon short enough to stow in that space and to fight with if he had to bail out. A modern assault rifle, for all its virtues, was long, and length was the very thing a tank crew could not afford. So the Meters 301 stayed, clipped inside American armor, long after the infantry had moved on. It remained standard for the crews of the Meters 60 main battle tank into the 1990s. Crews carried Meters 301 guns through the Cold War and into the Gulf War of 1991, and some kept them even after that fighting was done. The picture is worth holding still. A Cold War tank crewman, parked in the Fulda Gap in West Germany in the early 1980s, waiting for a Soviet armored assault that everyone feared and no one wanted, has a Meters 301 stowed inside his vehicle. The gun beside him was designed 40 years earlier, stamped out of sheet metal by a company that made car parts, to arm exactly the kind of man he is. Nothing better had been found for his particular need in all that time. The weapon that the Army had almost been ashamed to adopt was still riding into position against the most modern army on Earth, because for a man in a turret, cheap and short and reliable enough had never stopped being the right answer. The Meters 3 was formally retired around 1992, and by then it had earned a distinction no one had planned for it. It was the longest-serving submachine gun in United States military history, roughly half a century in the hands of American soldiers. In total, more than 650,000 had been built across all its versions and makers. A weapon designed to be a disposable wartime expedient had outlasted the Thompson it replaced, outlasted the war that created it, and outlasted nearly every weapon that had been meant to make it unnecessary. There is no myth left to correct here, only a ledger to close. The final accounting of the Meters 3 is a study in trades. It was cheap, and its cheapness showed in loose tolerances and a plain finish. It was ugly, and its ugliness was the visible cost of its price. It was limited, with short range and fixed sights and a single-feed magazine that jammed in the mud. And it was, against all of that, nearly unkillable as a design, sound enough in its essentials to serve for 50 years. Every advantage it carried was paid for somewhere. Every weakness it carried was the price of an advantage. The gun was a balance sheet made of steel, and the balance came out, improbably, in its favor. The Army had asked a small and unglamorous question in 1942. It had asked how to arm the men whose hands were already full, cheaply and quickly, and in enormous numbers. The answer it found was a weapon it could barely bring itself to be proud of. The answer it found would not go away. The gun the Army was ashamed to issue became the gun it could not manage to retire. The problem was never complicated. The good gun cost too much. That single fact set everything in motion. The Thompson was excellent and expensive, and a world war needed automatic weapons by the million, not by the thousand. Across the Atlantic, the crude British Sten had already proven that a working submachine gun could be stamped and welded together, cheaply, by workers who had never made a gun. An American officer willing to be embarrassed, Rene Studler, carried that lesson home. A failed first attempt, the Meters 2, taught the hard truth that a clever shortcut is worthless if the factory cannot execute it. And so a small team, George Hyde on the design and Frederick Sampson on the tooling, drew a gun down to the machine that would make it, in the space of about 2 months. They handed the work to a company that stamped headlight parts, and Guide Lamp turned pressed steel into a weapon that cost about $21 instead of $200. It fired from an open bolt on the simplest of blowback actions, its heavy bolt riding on guide rods so that dirt and loose tolerances scarcely mattered. It had one bad part, a cocking handle of poor steel that broke when dropped, and the improved Meters 301 fixed it by deleting it entirely and cutting a finger hole in the bolt. The gun went to the men it was drawn for, the tankers and drivers and radio men and paratroopers whose hands were already full, and it escaped its narrow assignment into Normandy, the Ardennes, and the islands of the Pacific. It had a weakness, a cheap single-feed magazine that jammed in mud and cold, and the men who cursed it in the snow learned to trust it anyway. Then it refused to end. It fought in Korea and Vietnam. It spread to more than 30 nations, and it rode inside American tanks for half a century, into the Gulf War and out the other side. The question the Cold Open asked was how to arm millions of men when the good weapon costs too much and takes too long to build. The Meters 3 was the answer, and the answer was uncomfortable. You arm them by surrendering pride. You accept ugly. You stamp the weapon out of sheet metal in a factory that makes car parts, you build the cheapness into every loose tolerance and plain line, and you trust that good enough, made by the hundreds of thousands, will beat excellent made by the few. It worked. It worked so well that the expedient outlived every proper weapon sent to replace it. The Army built it to be cheap enough to forget. History kept it long enough to remember.